2, I can say x times y is equal to, or is actually greater than, either number. So greater than x, and when I say x times y, it's also greater than y. So two numbers that could do this is I know I can pick a random number like 3, and for y, let's pick something like 1 and see if it's greater than both. So this would be 3 times 1 is greater than 3. This is 3 is greater than 3. Is that true?
Yeah.
No. Those are equal. So this is your counterexample because you disproved that statement. So here's the answer for number 3. So I have to just highlight where T, W, and S are. And a plane is a flat surface. So if I connect these, the other point is going to be X. So X is your answer. So when I'm naming this, if I have this small letter right here, I can name it just as line T. The other ways I can name it is just by picking 2 letters on the line. So if I pick D and F, I could put DF here and then just put the symbol for a line. I can do this with any of the letters, so I could also say EF, put the line. I can say DF, or actually DE, I haven't said yet, and put the line. And I can also write it backwards, so I could say FD, FE, and ED as lines. To understand this one, we got to first define what skew means. So skew is just non-coplanar. It's a line that is non-coplanar. So basically this one is not parallel. Not parallel. And not on the same plane. Not on the same plane. Okay, now that I have the definition, I'm going to look for GC, and it's right here. Now the line that is skewed to that is not parallel, so let's see which ones were parallel. So BF, that would be parallel. DH, parallel. AE, parallel, so it can't be any of those. And not on the same plane, so it can't be GH, can't be CD. Can't be AC, can't be EG. So what's an answer? FH, okay. Not on the same plane and they're not parallel. Anything else? BD. What else? EF. And then one more? And AB. So these are all answers that are skew lines to CG. Okay, if I'm looking for something that is parallel to this plane, and I want to say another plane that is parallel to that, I already identified plane ACEG, so I'm just looking at the plane that will never touch it. If I pick ABEF, those still intersect at AE, so that can be an answer. All the other ones can't be. The only one that will work is this one because they'll never intersect. So to write that one out, it is plane BDF. And we don't have to put the H. If you want to put the H, it's still correct.
Wow.
But you only need a minimum or a max or minimum, sorry, of 3 letters. So I could write BDFH or just plain BDF. Pick any of the 3 letters that are on this plane. So you have 4 to choose from. Okay, to understand this, think about when we did the popsicle sticks, right? So this was a whole popsicle stick. If I break it up, all I need to do is add 19 and 3. And this gives me 22. So AC is equal to 22. AC. Number 9 is the same thing as number 8. It just seems more complicated because we're dealing with binomials. So EF is going to be 5W plus 28. FG is 7W plus 20. And the whole thing, EG, is equal to 36. 36. So, same thing as number 8. I have EF plus FG, these segments. This is my segment addition postulate. So EF plus FG is equal to EG. My EF is going to be 5W plus 28, so now I'm just substituting it in. Plus 7W plus 20 is equal to 36. 5W plus 7W, that's going to be 12W. Combining like terms, 28 plus 20, that's going to be 48, is equal to 36. Subtract 48 both sides, and you'll get 12 equals 12W. Divide by 12, and this is going to be W is equal to -1. So now for part A, you have to find the value of W. So W is equal to -1. So we only have solved part A. To find EF and FG, I'm going to make some room and erase this. Alright, so I know that EF is equal to 5W plus 28. Plus 28. So the way I need to solve this is just by plugging in what W equals, which we found out was -1. So I'm going to say 5 times -1 plus 28. That's going to be -5 plus 28, and this is 23 is what EF equals. Now to find FG, we're going to do the same thing. FG is 7W plus 20. So this is 7 times -1 plus 20. -7 plus 20, and this gives you 13 is equal to FG. So EF equals 23, FG equals 13. And W was equal to -1.
Do you like using that little thing?
And so we have DOE. So the way you read this is DOE, right there, that angle is going to be equal to 23 degrees. And COD is equal to 20 degrees. Then what is the measure of angle COE, which is the entire measure? So here you're going to be doing the same kind of thing as before with the segment addition postulate. This is the angle addition. So all you need to do is say what's 20 plus 23 to find the entire one. So angle COE is equal to 43 by adding 20 and 23 degrees.
Start now.
Alright, so you got to use Pythagorean theorem. And the way you got to do this is the longest side is always your C. So this is going to be 5 squared here equals 3 squared plus B squared. 3 times 3 is 9 plus B squared equals 25. So now subtract 9 both sides. You get 16 equals B squared. Square root both sides, and B will equal 4. Alright, for this one we just need to know the vocab of how I say a 90 degree angle. So 90 degree angle would be perpendicular.
Perpendicular bisector.
Perpendicular would be 90 degrees. Now this right here, this notation, that means that they are both equal. So when you're cutting things in half, you're bisecting. So this would be a perpendicular bisector is your answer. Okay, to find AB and BC. So AB, so A is -7. B, I'm going to subtract it from negative 4. So the difference would be keep, change, change. And I want the absolute value of this. So it's going to be absolute value of negative 3.
3.
And it's going to be 3. You can also count, but I want you to get in the habit of doing this. So then when we do the midpoint, you know how to do it. It's just subtract the two numbers and divide by 2 if we were finding the midpoint. So now that's AB is going to be 3. BC, I could also count and see that's 2, or say negative 4 minus negative 2. And this is going to be keep, change, change. So negative 4 plus negative 2, or plus positive 2 is negative 2. Absolute value of that is 2. So are these congruent?
No.
So no, they are not congruent. Okay, in the figure not drawn to scale, MO, segment MO, bisects the angle LMN. So the measure of angle NMO is 6x plus 19, so I'm going to start labeling. And measure of angle LMO is going to be 9x minus 14. Solve for x and find the measure of angle LMN. I underlined bisects because you need to know that that word means that it's cutting it in half. So when it's cutting in half, all we need to do is set these angles equal to each other. So let me first write angle LMO is now congruent to angle NMO. And I just need to plug in and solve for x. So LMO is 9x minus 14 and 6x plus 19. Now solve for this. So here's my line in the middle. These are on opposite sides, so I'm going to do the opposite operation. This is 3x minus 14 is equal to 19. Add 14 both sides. So add 14, you get 33 equals 3x. Divide by 3 both sides. So x is equal to 11. So now to find the measure of angle LMO, I just need to take this 11 and plug it back in. So this is going to be 9 times 11 minus 14. So that's 99 minus 14, which is going to be 85. Alright, before you start this one, you want to change.
Question.
I don't think that that's how it works.
Alright, so after I convert 80 centimeters into 0.80 meters, now I can multiply. So this becomes 5 times 0.8. So this is going to be 40. And there's only one decimal spot, so it's 4.0 meters is my area. And I need to multiply it because the area of a rectangle is equal to base times height. So I just plug in base and the height. Alright, so here's the distance formula. And I'm going to first label these. This is x, y, x, y. This will be your first coordinate, and this is your second. So now when I plug this in, my x2 is negative 3. My x1 is going to be negative 1, so make sure to put that minus first, plus y2, which is going to be 0, minus y1 is 5 squared. Square root this is equal to your distance. Distance is equal to the square root. Negative 3 minus negative 1 plus positive. So this is negative 2 squared, and negative 2 squared is going to be 4. Plus 0 minus 5, so this is negative 5 squared, 25. So your distance here is equal to the square root of 29. Okay, so here's the midpoint formula for number 7. And I have that this is going to be x1, y1, x2, y2. So now after I substitute, it'll look like this: 2 plus 8 over 2, 6 plus negative 4 over 2. Make sure that you have this comma because your answer is going to be in a coordinate. So 2 plus 8 is 10. 10 over 2, that's going to be 5. For your y, it's going to be 6 plus negative 4, that's 2. 2 over 2, 1. So your answer for the midpoint is 5, 1. Okay, on this one, to start it, you have to have the area of a circle memorized. So this is going to equal pi r squared, or pi r r. So now the area of a circle is equal to pi, which is 3.14, so I'm going to plug in 3.14, times your r is 7, times the other r, 7. So this becomes 49 times 3.14 equals the area of a circle. So now with the decimal spots, move it over twice. And after you multiply it, you'll find your answer is 153.86. So for number 9, I already plotted the points and connected the dots, and it makes a triangle. So now to find the perimeter, we know the perimeter is just when you add up all the sides. So I need to count how many, the distance of this. So it's 1, 2, 3. It's the distance here. From here it's 1, 2, 3, 4. And now to find this distance from here to here, there are 2 ways to do it. So I can either use a squared plus b squared equals c squared, since it's a right triangle, or I can use the distance formula. D equals the square root of x2. Alright, most people would prefer this one, the Pythagorean theorem, so we will use that for the example. So both of these are legs, the 4 and the 3. So I can put the 4 squared here, plus 3 squared is equal to c squared. 4 times 4, 16. 3 times 3, 9, which equals c squared. This is going to equal 25. Square root both sides. Square root of 25 is 5, which equals c. So now that we have all 3 sides, I still need to find the perimeter by adding this up. So it's 5 plus 3 plus 4.
12.
And that's going to be 8 plus 4, 12. So, alright, to find the area of the shaded region, this one's going to be 5. We know that this whole side, from here to here, is 10. So half of this would be 5. So if you can imagine, I'm going to take this triangle, and since this triangle is the same as this one, really when I put them next to each other like this, what I have is a square. So instead of doing the area of a triangle equals base times height divided by 2 twice, I'm going to actually just say I have one whole square since I have 2 halves of a triangle. If I put it together, it's going to be a square. So what's 5 times 5? 25 meters squared is your answer for the area of the shaded region.